So good morning, welcome to Sakal Vijay YouTube channel. So once again, good morning, welcome to our Diploma Basic Engineering Mathematics classes. So today we are going to start new chapter, that is partial fractions, very important chapter. It will be very useful for even Diploma Mathematics, Engineering Mathematics, and as well as Intermediate Mathematics, or for all board examinations. It will be useful for all competitive entrance examinations also. So my dear children, so please understand this the importance of this chapter. So let's have a discussion on partial fractions. This is chapter 2. Chapter 2, partial fractions. Partial fractions. Weightage is 5 or 6 marks. 5 or 6 marks. Okay. Definitely it will be started soon. Right, first, so let's have a discussion before going to discuss. So this syllabus will be useful for common to all. So next, first concept let us discuss. We have polynomial. What is meant by polynomial? Polynomial. So that means let us discuss the general form of a polynomial. General form of a polynomial. An expression of the form a0 x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus a3 x to the power of n minus 3 and plus so on dash an. Okay, where n must be positive integer. N is a positive integer. Okay, and thank you Sanjay, and a0, a1, a2 and so on dash an are real. That means real numbers. Is called nth degree polynomial. In x. So this is the concept of the polynomial. So polynomial will have the finite number of terms, and also the exponent must be positive integer. It should not be negative, or it should not be any radical symbol, any fraction. So okay, Ravinder, good morning. An expression of the form a0 x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus a3 x to the power of n minus 3 and so on an, where n is a positive integer. The a0, a1, a2, an are the coefficients or the real numbers, is called nth degree polynomial. Its degree is n. So nth degree, generally denoted by f of x, g of x, h of x, and so on. So now this can be written like this. F of x equals to, we can write like this, a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus a3 x to the power of n minus 3 plus so on dash dash plus an. So this is meant with a polynomial. So next, second one, rational fraction. Rational fraction. This is very important concept. You may be asked in the examination. Define rational fraction and give some examples. This may be asked in the examination. See, rational fraction definition: if f of x and g of x, f of x and g of x are two polynomials, already we have discussed, are two polynomials, then f of x by g of x, where g of x does not equal to 0. Good morning. Where g of x does not equal to 0 is called a rational fraction. So this is the definition of the rational fraction. So now examples. 1 upon x plus 2. Second, 1 upon x into x plus 1. Third, x square plus x plus 1 by x cube plus x plus 1. And next, x to the power of 4 plus 5 by x to the power of 5 plus x square plus 7. So all are called, actually you may take another example also, x cube by x minus a, x minus b into x minus c. So these are the examples for the rational fractions. So next one is, we shall define, next one is proper fraction. This is also very important. You need to remember this one, proper fraction. Okay, Srinivasa Kumar, Mandalaparthi, Sandeep, welcome. So proper fraction is also a rational fraction, you remember. So that means a rational fraction f of x by g of x, f of x upon g of x is called a proper fraction. If the degree of, as for the degree we can classify. Thank you. If the degree of f of x is less than or lesser than degree of f of x is less than the degree of g of x. That means the degree of numerator is less than degree of the denominator, then the rational fraction is called proper fraction, is called a proper fraction. If the degree is important, according to the degree we can classify rational fractions into proper fraction. So examples. So let us write the examples. These examples are very, very important. Examples. First example, 1 upon x plus 2. You see, 1 means degree is 0, here degree 1. Second, 1 upon x into x plus 2. These are all proper fractions only. And next, x square plus 2 upon x into x cube plus 5. Next, fourth one, 2x plus 1 by x square minus 5x plus 6. So these are the examples for the proper fraction. Proper fraction. Next, fourth one, improper fraction. Improper fraction. So now improper fraction is also a hello electronics for you. How are you? Improper fraction. Improper fraction. Improper fraction. See, improper fraction is also a rational fraction, but we need to write like this. A rational fraction, a rational fraction, a rational fraction, f of x by g of x is called an improper fraction. An improper fraction. Improper fraction. Yes, diploma chapters only I have been dealing. If the degree of f of x is greater than or equal to g of x. So this is the definition of the improper fraction. So my dear children, those who are appearing for the diploma, you need to remember all these definitions. Okay, examples right now. Examples. First example, see, x plus 2 by x plus 3. Degree of x plus 2 is 1, degree of x plus 3 1, equal. This is also improper fraction. Now x cube by x minus 1 into x minus 2. See, degree of numerator is 3, degree of denominator is 2. So it's also improper fraction. One more example, x cube upon x minus a into x minus b into x minus c. And next, 2x to the power of 4 plus 5 by x square minus 5x plus 6. So these are the examples for the improper fractions. So you can give your own examples also. So next, fifth concept is what is meant by the partial fractions. Partial fractions. Partial fraction. This is our chapter name. What do you mean by the partial fraction? Can you give anybody? What is meant by the partial fraction? So that means if any rational fraction can be split into two or more proper fractions, then each of the proper fraction each of the proper fractions is called a partial fraction. So let us talk about more about this one. Let us discuss. Right. So let us discuss. So fifth one. So now consider two proper fractions. One is 1 upon x plus 2 plus 1 upon x plus 3. Add these two. What do you get now? Let us see. So that means if you add these two, x plus 2 into x plus 3 is the LCM. So now x plus 2 cancel, we have x plus 3 plus x plus 3 cancel, we have x plus 2. If you simplify this, you get 2x plus 5 upon x plus 2 into x plus 3. That means what do you observe? The sum of two partial fractions equal to a partial fraction. Again, you think in reverse order, conversely. So that means now we can write like this. Now we can have this 2x plus 5 upon x plus 2 multiplied by x plus 3 can be rewritten as 1 upon x plus 2 plus 1 upon x plus 3. That means this proper fraction has been split up as a sum of two proper fractions. So therefore 1 upon x plus 2 and 1 upon x plus 3 are called partial fractions of 2x plus 5 x plus 2 into x plus 3. That means we can find out the partial fractions of given either proper fraction or improper fraction also we can find out. For example, improper fraction is there. We need to make it into the proper, then we need to find out. So that means the method of finding the partial fractions for proper or improper fraction is called resolving into the partial fractions. So now that note right up. Note. So now splitting a proper or an improper fraction as a sum of two or more partial two or more proper fractions is called resolving into partial fractions. This is our important step, resolving into partial fractions. So actually in this chapter we concentrate how to resolve a proper or improper fraction into the partial fractions. So that means we discuss the methods. So next we discuss methods to resolve a rational fraction, either it may be proper or improper, rational fraction into partial fractions. Okay, first, so now let us consider a rational fraction. So now you are able to define rational fraction of the form f of x by or f of x upon g of x. So in that we shall discuss method number 1 or type number 1, you can say. That is also type 1 also you may call. Type 1. So it depends upon the denominator. You see this denominator, g of x. So that means if the denominator g of x contains non-repeated linear factor means degree is 1, linear factors ax plus b of the form ax plus b, x plus 2, x plus 1, x plus 2, like that. So then for each linear factor, there exists a partial fraction of the form a by ax plus b. We need to write constant by that ax plus b. So here a is a constant, Here a is a constant. So that can be evaluated using the methods that we will discuss. This is type 1. So type 1. Now let us go for the problems now. So now problems related to problems based on type 1. So today let us discuss problems based on type 1. Second year JE class already given the notification, Anna. So first question, problem number 1 write down. If 3x upon x minus 2 times x plus 1 equals to 2 upon x minus 2 plus a upon x plus 1, then find a. That constant we need to find out. Then find a. This is the question. Okay, let us solve it now. Solution. First given write down 3x upon x minus 2 into x plus 1. This is the proper fraction, equal to given partial fractions 2 upon x minus 2. So evening 4:30 for a upon x plus 1. Now 3x upon x minus 2 into x plus 1. Here LCM is x minus 2 times x plus 1. See, x minus 2 cancel, 2 into x plus 1 plus x plus 1 cancel, a times x minus 2. So comparing on both sides, this gets cancelled. We have a times x minus 2 plus b times x plus 1 equal to, you get 3x. This is called identity also. With the help of this identity, we can find out the a value. How to find out the a value means we need to follow suppressing method. That method is called suppressing method. Suppressing method means here we need to suppress this x plus 1 factor. How could you suppress x plus 1 factor? Equate x plus 1 equals to 0. So then you get x is equal to minus 1. That means if you put x is equal to minus 1 in this one, you get a value. That is called method of suppressing. So now put x is equal to minus 1. So that implies a times minus 1 minus 2 plus b times minus 1 plus 1. That will be 0 equal to 3 times minus 1. It has been suppressed. So we get minus 1 minus 2 minus 3a plus 0 equal to minus 3. So minus 3a equals to minus 3. We need a value. So a equals to minus 3 upon minus 3. So minus 3 1 ja minus 3 1 ja. So 1. Therefore a equals to 1. So you need to write all these steps. Definitely you will get good marks in the examination. So now you can join. You can continue. Watch regularly. This first problem. So let us move to the second problem now. Second problem. If 1 upon x times x plus 3 equals to 1 upon 3x plus a upon x plus 3 then find A, then find A, then find A. Okay, first subscribe Hamad, like and click the bell icon so that you will get the notifications every day. What is the answer? Okay, let us solve it. Solution: given 1 upon x times x plus 3 equal to 1 upon 3x plus a upon x plus 3. So 1 upon x times x plus 3 equal to LCM is 3x times x plus 3. So 3x times x plus 3 divided by 3x. 3x cancel. We have x plus 3 plus x plus 3 cancel. We have 3ax. So comparing the numerators, this actually gets cancelled. So we have like this. We have like this. Very important step need to be remembered here. X times x plus 3, x times x plus 3 cancel. We have like this. So 1 equals to x plus 3 times 3ax upon 3 will be there. So now the cross multiplication, x plus 3 times a 3ax equal to 3. So we need to suppress x plus 3. Suppress x plus 3 means x plus 3 equal to 0. In rough part, x is equal to minus 3. Put x is equal to minus 3. Put x is equal to minus 3. So then what do you get now? Minus 3 plus 3, 0. We can write 3a times minus 3 equal to 3. We have this is minus 9a equal to 3. A equals to 3 upon minus 9. 3 1 ja, 3 3 ja. So this is minus 1 upon 3. So therefore, what is the value of A? Yes, negative 1 by 3. Negative 1 upon 3. A value has been evaluated. Right. Shall I move to next question? Are you ready? Third problem. If 1 upon x minus 5 times x minus 7 equals to a upon x minus 5 plus 1 upon 2 times x minus 7. Then find A. Capital A. Okay, are you there? Can you solve it? Okay, let us solve it. Given, so 1 upon x minus 5 times x minus 7 equals to a upon x minus 5 m2, okay, x minus 5 plus 1 upon 2 times x minus 7. Now 1 upon x minus 5 times x minus 7. Here LCM is 2 times x minus 5 times x minus 7. So 2 times x minus 5, x minus 7 divided by x minus 5. X minus 5, x minus 5 cancel. We have 2a times x minus 7 plus 2 times x minus 7, 2 times x minus 7 cancel. We have x minus 5. Basically what happens means this and this will be cancelled. We have 2. So that means remaining part is, you check here, you can have like this. 1 equals to 2a times x minus 7 plus x minus 5 upon 2. If you cross multiply, you will get identity. That is called identity. So now we get like this. 2a times x minus 7 plus, go back once again, x minus 5. So x minus 5 equals to 1 multiplied by 2. Suppressing method. Suppressing method means what we need to do? X minus 5 is equated to 0. That means indirectly we are going to find 0 of the polynomial x minus 5. The 0 of the polynomial of x minus 5 is x is equal to 5. So that means put x is equal to 5. If you put x is equal to 5, this becomes 0. Because 5 minus 5 is 0. X minus 5 is 0, you can directly write. So 2a times, instead of x, 5 is replaced. 5 minus 7 plus 0 equal to 2. This will be minus 2 into 2, minus 4a plus 0 equal to 2. So minus 4a equals to 2. Our aim is to find a value. A is equal to 2 upon negative 4. 2 1 ja, 2 2 ja. That is 1 upon negative 2 is minus negative 1 upon 2. So therefore, a equals to negative 1 upon 2. That's all. So now the problem number 4. Problem number 4. If x upon x plus 4 whole square equals to 1 upon x plus 4 plus a upon x plus 4 whole square, then find a. So this was given. So April 2017. In all common examination papers it was given. This question was given. Previous examination question this is. Right. Solution. So given x upon x plus 4 whole square equal to 1 upon x plus 4 plus a upon x plus 4 whole square. So now what shall we do now? Let us take the LCM. X upon x plus 4 whole square. Here x plus 4 whole square is the LCM. So x plus 4 whole square by x plus 4. X plus 4 plus this will be a. Now actually x plus 4 whole square, x plus 4 whole square cancel. We have now, we'll get like this. A plus x plus 4 equal to x. Suppress x plus 4. That means x plus 4 equal to 0. X is equal to minus 4. So put x is equal to minus 4. That means a plus 0 equal to minus 4. So therefore a is equal to negative 4. This answer. So fifth question. If x upon x plus 3 whole square equals to 1 upon x plus 3 plus a upon x plus 3 whole square, then find a. This question was given April 2016 and October 2017. Previous questions. Okay, let us solve it now. Solution. Given x upon x plus 3 whole square equals to 1 upon x plus 3 plus a upon x plus 3 whole square. So x upon x plus 3 whole square equals to, what is the LCM? Here x plus 3 whole square is the LCM. X plus 3 whole square by x plus 3, we get x plus 3 plus x plus 3 whole square cancel, we have a. So that means the denominators will cancel, x plus 3 whole square. So we have now a plus of x plus 3 equal to x. Let us suppress x plus 3. Suppress means equated to 0. X plus 3 is equal to 0. We get obviously x is equal to minus 3. So now put x is equal to minus 3. What do you get now here? A plus x plus 3 is 0. This is negative 3. So therefore a equals to negative 3. This is the answer. Okay, M2 I will start, Nana. Just I am going through the question papers and I don't have the test book actually. Could you follow test book? Vinayak AV, hello. Hello, how are you? Sixth problem. Let us move to the sixth problem. If 1 upon x plus 1 times x plus 2 equals to a upon x plus 1 plus 1 upon x plus 2, then find a. This question was given April 2018. So this will be useful for all competitive entrance examinations, board 11th class and 12th class, diploma engineering, and this is for all classes it will be useful. Right. Now the solution. Let us move to the solution now. So now given 1 upon x plus 1 times x plus 2 equals to a upon x plus 1 plus 1 upon x plus 2. Right. So now 1 upon x plus 1 times x plus 2 equals to, here LCM is x plus 1 times x plus 2. Now x plus 1 cancel, a times x plus 2 plus x plus 1 you will be getting. Now the denominator will be going to be cancelled, this one and this one. So now we get like this, a times x plus 2 plus of x plus 1 equals to 1. I already told you this is called identity. So now using suppressing method, x plus 1 need to be suppressed. Suppressing means equated to 0. X plus 1 equals to 0. You get x is equal to -1. So put x is equal to -1. So what happens? A of -1 plus 2. Obviously x plus 1 becomes 0 here, equal to 1. So 2 minus 1 is 1. So a into 1, a plus 0 equals to 1. So therefore a equals to 1. That's our answer. Right. Seventh question. If 1 minus x plus 6x square upon x minus x cube equals to a upon x plus b upon 1 minus x plus c upon 1 plus x, then find a. This is the question. Thank you, Vinayak. Thank you. Okay, solution. Here given 1 minus x plus 6x square upon x minus x cube equals to, here LCM also, first let us write whatever given, a upon x plus b upon 1 minus x plus c upon 1 plus x. If you take the LCM, you get same x minus x cube only, because 1 minus x into 1 plus x is 1 minus x square into x. So we get like this, x minus x cube. This will be the LCM. Thank you, Rishikesh. Thank you. So 1 minus x plus 6x square upon x minus x cube equals to, here LCM is x minus x cube, means you can write like this, better. This x minus x cube you can write like this, x times 1 minus x times 1 plus x. See, x gets cancelled. We have a times 1 minus x into 1 plus x and plus 1 minus x cancel, bx times 1 plus x and plus 1 plus x gets cancelled. We have c into x into 1 minus x. So now this equals to 1 minus x plus 6x square upon x minus x cube. So now 1 minus x into 1 plus x is 1 minus x square into x into 1 x cube. So that means this is a times 1 minus x into 1 plus x plus b times x times 1 plus x plus c times x times 1 minus x upon, you can write, this is x minus x cube. So now, so this gets cancelled. Now this is equated to this. So that means x cancel, a into 1 minus x into 1 plus x. 1 minus x cancel, b into x into 1 plus x. 1 plus x cancel, we get c into x minus x into 1 minus x. So now we have an identity. Let's go back. A times 1 minus x into 1 plus x, a times 1 minus x into 1 plus x, plus, once again go back to the next previous page, b times x into 1 plus x, b times x into 1 plus x, plus c times, okay, c times, what we have, x times 1 minus x equated to this 1 minus x plus 6x square. 1 minus x plus 6x square. Our aim is actually, go back to the question, our aim is to find a value itself only. Only one value we need to find out, not b, not c. So that means we need to suppress the one factor. Check first of all in these two factors, check x into 1 plus x, x into 1 minus x. What will be the common factor? The common factor is, easily we can say x. X need to be suppressed. X need to be suppressed means x is equal to 0. That means put x is equal to 0. If you put x is equal to 0, you get like this. A times 1 minus 0 into 1 plus 0. See, very interesting, 0 into something 0 plus 0 into something 0 equal to 1 minus 0 plus 6 into 0 square is 0. So we get like this. A times 1 minus 0, 1, 1 plus 0, 1, 0 plus 0, 0, 1 minus 0 plus 0. So 1 into 1, 1, a plus 0, a, 1 minus 0, 1, 1 plus 0, 1. So therefore a equals to 1. This is the answer. So now we are going to the important part now. Yes, Vinayak, AB2 is equal to 1, I think so. 1 into 1, not plus 1. 1 into 1, 1. Yes, yes, yes. Now 8th question. Resolve following into partial fractions. Into partial fractions. Partial fractions. This is the 5 marks question now. We are going to discuss. In that first question, what is the first question? 3x upon x minus 2 into x plus 1. So this question was given March 2016, next April 2015, next October, November 2010 also. So 3 times asked in the previous question. This is very, very important. So now this is called actually proper fraction. We need to find out the partial fractions, means we need to split into the two proper fractions, sum of a two proper fractions, that is called a resolving into the partial fractions. So that means now this is type 1, model number 1. First consider like this solution. Let us say 3x upon x minus 2 into x plus 1 equals to, here the denominator is consisting of two factors, they are linear factors. For each linear factor there exists one partial fraction of the form a upon x minus 2 for x minus 2 plus for x plus 1 another partial fraction of the form b upon x plus 1. So now we need to find out a comma b. So that means 3x upon x minus 2 into x plus 1. Partial fractions means splitting of a proper fraction into the two or more proper fraction is called a partial fraction. Already discussed in the chapter. After completion of this session offline, watch once again the video. X minus 2 into x plus 1 equals to, here LCM is x minus 2 multiplied by x plus 1. Okay. Ganesh Yadav, after long time, where had you been? So here x minus 2 x plus 1 divided by x minus 2, you get a times x plus 1 plus x plus 1 gets cancelled, b times x minus 2. Now here the x minus 2 x plus 1 x minus 2 x plus 1 cancel. Okay, now we get like this. We have see a times x plus 1, a times x plus 1 plus b times x minus 2 equal to 3x. Now to get a, we need to suppress x minus 2. You remember, all of you. To get b, you need to suppress x plus 1. First suppress x minus 2. Means x minus 2 is equated to 0. You get x is equal to 2. So that means put x is equal to 2. That implies it will be suppressed a times 2 plus 1 plus b times 0 x minus 2 3 times 2. So that means 3a plus 0 equal to 6. 3a equal to 6. A equals to 6 upon 3. So that means 3 1 ja 3 2 ja. A value obtained. Now this time to get b, suppress x plus 1. X plus 1 is equated to 0. That means x is equal to negative 1. Put x is equal to negative 1. See what you get now. It has been suppressed. So we get like this. A times 0 plus b times negative 1 negative 2 equal to 3 times negative 1. So a into 0 0 plus negative 3b equal to negative 3. So negative 3b equals to negative 3. Therefore b is equal to negative 3 by negative 3, whose value is 1. Now we know a value and b value. Now partial fractions we have to write. Hence partial fractions, hence 3x upon x minus 2 into x plus 1 equals to, we have like this, a upon x minus 2 plus b upon x plus 1. Let us substitute a value and b value. What is a value? 2, b value is 1. So this equals to 2 upon x minus 2 plus 1 upon x plus 1 and solved. Okay, shall I move to next question? Second question. Second question. 1 upon x plus 9 into x plus 7. Resolve into partial fractions. Resolve into partial fractions. This was given October 2013 and April 2011. Okay, let us solve it now. Solution. Let 1 upon x plus 9 into x plus 7 equal to, so the denominator is consisting of two linear factors, so there exist two partial fractions of the form. For x plus 9 there exists a partial fraction of the form a upon x plus 9, plus for x plus 7 there exists a partial fraction of the form b upon x plus 7. Okay, now that implies we can write 1 upon x plus 9 into x plus 7 equal to, here LCM is x plus 9 multiplied by x plus 7. X plus 9 gets cancelled. A times x plus 7 plus x plus 7 gets cancelled. B times x plus 9. So now, so cancelling x plus 9, x plus 7, x plus 9, x plus 7 on both sides, we get like this now. A times x plus 7 plus b times x plus 9 equals to 1. Now what shall we do now? We need to suppress x plus 9. Suppressing x plus 9 means x plus 9 is equated to 0. So we get x is equal to minus 9 or 0 of the polynomial x plus 9. Verification, if you go back, that will become the verification. So now put x is equal to negative 9. So a times minus 9 plus 7, b times 0 equal to 1. So minus 9 plus 7 is minus 2, that becomes minus 2a plus 0 equals to 1. Minus 2a equals to 1, that implies a equals to negative 1 by 1 upon 2. This is the value of a. Now we need to suppress this x plus 7. Having been suppressed x plus 7, you see x plus 7 becomes 0. That means x is equal to negative 7. So this time put x is equal to minus 7. So a times 0 plus b times negative 7 plus 9 equal to 1. 0 plus 2b equals to 1. 2b equals to 1. So therefore b equals to 1 upon 2. Now we know the a value and b value. Substitute here, you will get the answer. So negative 1 upon 2 by 2 upon x plus 9 plus 1 upon 2 by x plus 7. So hence partial fractions we shall get like this. Hence 1 upon x plus 9 into x plus 7 equals to a upon x plus 9 plus b upon x plus 7. So this we can write negative 1 upon 2 x plus 9 plus 1 upon 2 x plus 7. This positive first, negative later. You can write this is 1 upon 2 times x plus 7 minus 1 upon 2 times x plus 9. So these are the partial fractions. So thank you. So we shall continue tomorrow. Once again watch this video 2 or 3 times. You will not lose a single mark in the examination. All of you just like, subscribe and share to your friends and click the bell icon.